Okay, this is going to be an Algebra 2 video. This is the intro to Unit 4. There's a couple concepts we have to cover we're going to use in Unit 4. The first one is reducing a square root. What you should try to do is divide by 2, 3, 5, 7, 11, 13. Okay, these are all your prime numbers. So start, if you can divide by 2, do it. 2 and 40. Divide by 40, 2 and 20. Divide 20 by 2, 2 and 10. 2 and 5. When do you stop? You stop when both numbers are prime. Cross off the double branches. I'm circling, since it's a square root, I circle like pairs. Now, I can take one item per thing I circle. It becomes multiplied. What I don't circle goes on the inside. So this is 4 square root of 5. Okay? This, 275. I can't divide 75 by 2. I can divide it by 3 though. 325. 25, I can't divide by 3 or 2, but I can 5 and 5. Now, in this case, I only have one pair. So that goes on the outside. These that I didn't circle go on the inside, and it's multiplication. So 5 square root of 6 is how you reduce that. Okay? All right? So you go ahead, pause your video, try to reduce those. Okay? Now, let's talk about rationalizing a square root. You're not allowed to have square roots in the denominator. So what we can do to get rid of those is multiply top and bottom. So that's square root of 40. That is square root of 25. Now, when you multiply a square root times a square root, that result is just whatever was inside that square root. Now, what I got to do is I got to break down the square root of 40. That's 2 and 20. That's 2 and 10. That's 2 and 5. Here's my pair. Okay? So outside the square root, I have one of those. Inside, I have 2 times 5, which would be 10. Okay, that comes from 2 times 5. Okay, over 5. Now, what you should do, can you reduce that? In this case, I cannot. So that would be my answer. This I want to multiply by square root of 8, top and bottom. So that's just going to be 8. That's going to be the square root of 88. I break down the square root of 88. That's 2 and 44. That's 2 and 22. That's 2 and 11. There's a pair. So what I have on the outside, one of those 2's, 2 times 11 would be on the inside, and there's an 8. Well, I can reduce that. They can both be divided by 2, so that is going to be 22 over 4. If you put a 1 there, that is more than adequate. Okay, here I'd multiply by 5. Okay, square root of 5. So that's square root of 15 over 5. Now, if I go to break down 15, all right, 2 doesn't go in there, 3 and 5. Those are prime. I got no pairs. So that's just going to reduce and be that. Okay? You can pause your video and go ahead and work on those. Okay, now, let's talk about this. It's something new in Algebra 2. In Algebra 1, your teacher talked to you that, hey, you can't have a negative square root. Well, in Algebra 2, we're going to introduce the concept of complex numbers or imaginary. So the concept of imaginary is this could be written as -1 times the square root of 20. What the square root of -1 is this concept called I for imaginary numbers. Okay, you can't see that. Okay, I. Okay, all right. So, or I'll just do it this way. All right, so the idea is I break down this as 2 and 10, 2 and 5. There's my pair. On the outside, I have a 2. This is crossed off. Now, if I have a negative square root, I have to put an I out there. So I can just automatically sort of know I'm going to have an I out there. So that's going to be 3 and 21, 3 and 7. There's my pair, 3 and 7. Okay? So don't overcomplicate that. Okay? So you can try that one on your own. All right? Next concept are the powers of I. And here's what you need to know. I to the first is just I. I to the second is -1. I to the third is -I, and I to the fourth will be 1. And the reason for that, okay, all right, is if I took the square root of that, okay, square root of I squared, okay, square root of I squared, I equals square root of -1. That's where that comes from, okay? Now, here is the idea. The i's work in cycles. So if I assume I to the first is I, then I squared, okay, is -1. Okay, I to the third would just be I to the first times I squared. Well, what's I to the first? I. What's I squared? Negative 1. That's why it's negative I. Okay? All right, well, what's I to the fourth? That's I to the squared times I squared. Well, we know that that's negative 1 times negative 1, which would just be 1. So that's where that stuff comes from. Okay? Now, here's the idea. All of these work in cycles of 4. Okay? Now, what you got to do is if you divide 31 by 4, okay, all right, you get 7.75. All right, so, all right, here's one way you can remember that. You do it a couple different ways. All right, okay. The way you can remember that is 0.75 is 3/4. So what does that mean? That means it's I to the third, or that's going to be negative I. Okay? All right, and that's how you can do that. Okay? The other thing you can do is look at, all right, what's the next one after 32? 31 is 32. If I divide 32 by 4, I get a whole number. That means it's one less than this. Okay? Probably easier. Okay? So what I'm going to do is I'm going to do 60 divided by 4, which means that's 15. Okay, there's no decimal. That means it's got to be the I to the fourth thing, which would just be 1. 46 divided by 4 is 11.5. Well, what is that? What is 0.5 as a fraction? That's 1/2. Okay, so that's going to be 2. I to the second. I'm sorry, or 2/4 is probably a better way to look at that. That's 2/4. Okay, all right. Let me clean that up a little bit. Okay, that's 2/4. Okay, so I to the second, which is negative 1. Okay, 81 divided by 4 is 20.25. Well, what is that? That's 1/4. Okay, so that's I to the first, which is just I. Okay, so what you want to look at is where is this in increments of 4? If you get a whole number, the idea is that's something 4 over 4. Okay, and that's how you can do that. All right, so go ahead and pause your video. Go ahead and calculate these. Okay, moving on. Complex operations. Now, here's the idea. What this turns into, 12 plus 5i. All right, addition, I just bring these down. We learned about that. Okay, now, I can only combine, it's like like terms. The real parts, 12 minus 3 would be 9. I then can combine those. 5 minus 4i would be 1i, so that would be the answer. This is 9 minus 3i. What does this do? This changes these signs. Okay? So that's going to be positive 2, positive 9i. Okay? All right? So if I combine the 9 and the 2, I get 11. If I combine the negative 3 and that, I would get 6. That would be my answer. Now, multiplication. I'm going to use the box multiplication to help me. And let me show you what happens. And I got to explain this. Okay? 10 times 8 is 80. Negative 4i times 8 is negative 32i. 10 times 2i is positive 20i. Negative 4 times I times positive 2i would be negative 8i squared. Now, here is what happens. Here is the idea. Okay? I've got 80. These are very clear that these and these combine to negative 12i. Okay? Then I got negative 8i squared. Well, what happens with that? That's going to be negative 8 times negative 1, because we know that I squared is negative 1. So that's going to be 80 minus 12i. That's going to be positive 8. Well, now I can combine it with the 80. And I would get 88 minus 12i. We learned about this. This is box multiplication. I got to write this 2 times. That's the idea. So 2 minus 5i, 2 minus 5i. Okay, 2 times 2 would be 4. Negative 5 times 2 would be negative 10i. That would also be negative 10i. Negative 5 times negative 5 would be positive 25i squared. Okay, so what happens there? 4, those combine to negative 20i. That is 25i squared. Well, what do we know that I squared is? We know that I squared is negative 1. Okay, so that's going to be 4 minus 20i minus 25. If you combine those, that's negative 11. Okay, so a little bit of calculation. Just your I squared, big thing is I squared equals negative 1. Okay? All All right, so you go ahead and practice those. All right, now, just like with the square roots, we can't have these i's in the denominator. So what I have to do is I have to multiply by what they call the conjugate. So the only thing that changes is that. Okay, now what happens there? Okay, what's going to happen just as a shortcut? Okay, I'll show you in this bottom corner, then I'm just going to erase it. But what happens here is this. Watch. This is going to be 4. This is going to be 12i. This is going to be negative 12i. This is going to be negative 36i squared. Now, these go away. So I got 4 minus 36i squared. So that's going to be 4 minus 36 with a negative 1. So 4 minus negative 36, which turns that bottom part into 40. Okay? All right? Now, what could be a shortcut there for you? Just multiply first times last. That's all you really need to figure out. Because when these are conjugates, the middle disappears. You don't need to combine those. Okay? Now, I will need to do box multiplication for this other part. Okay? 5 minus 3i, 2 minus 6i. That's going to be 10. Okay? That's going to be negative 6i. That's going to be negative 30i. This is going to be positive 18i squared. Okay? All right? So I got 10 minus 36i plus 18i squared. So that's just going to be 10 minus 36i minus 18. Okay? So that's going to be negative 8 minus 36i all over 40. Okay? All right? We're not going to worry about reducing that. All right? You're good enough if you get it to that point. Okay? So here I would multiply by 8 plus 3i, 8 plus 3i. So what's going to happen in the bottom here, I just multiply first and last. Okay, so that's going to be 64 minus 9i squared. So that's going to be 64 minus 9 times negative 1. So 64 minus negative 9. So that's going to be 73 in the bottom. Okay, and I'm going to erase this here because I already showed you those calculations. Hold on. Good go. There we go. Okay. So then I want to multiply this up here. 9 plus 5i, 8 plus 3i. Okay, so that's 72. That's 27i. That's 40i. 5 times that would be 15i squared. Okay, so that's going to be 72 plus 67i. That's just going to be a negative 1 there, so negative 15. If I combine those, that's going to be 57 plus 67i. Okay? Let me clean that up. I don't think you'll see it off the board. 57 plus 67i all over 73. Okay, so what on this one I'd multiply by 5 plus I and 5 plus I. Okay? Now the bottom, that would be 25. Negative 1 times 1 would be negative 1i squared. So that's going to be 25 minus 1 times negative 1. So that's going to be a positive number, so that's going to be 26 in the denominator. And then I multiply these other ones over here. 10 minus 2i, 5 plus an I. So that's going to be 50, negative 10i, positive 10i. Oh, look at that, that one went away. And then negative 2i squared. Okay, so those went away. That's 50 minus 2 times I squared. So we know that that's 50 minus 2 times negative 1. Okay, so that's going to be 52. Okay, you could actually divide that. That actually would give you 2 as the final answer. Sort of crazy that that worked out that way. Okay, all right, so go ahead and practice those 2 on your own. Okay, the next thing we got to go into is this. Okay, all right, so the concept is, all right, I'm going to do a square root. I am going to square this, and I am going to square this. This is like distance. That's what that means. Now, anytime you square a negative number, it's going to become positive. So what I got is 36 plus 64, which is square root of 100, which would just be 10. Okay? Same thing here. I square this, okay? All right? Okay, so that's going to be 49 plus 24 times 24 is 576. You add those up, square root of 625, which is 25. Okay? All right? On this one, 4 squared plus negative 10 squared. Okay? All right? That's going to be 100. And that's going to be 16 plus 100, which is 116. I have to break that down. It'll be 2 and 58, 2 and 29. There's my pair. So it'll be 2 square root of 29. Okay. You guys go ahead and practice those two on your own. Okay. The last part of the video, number classifications. We got real or complex. All right. You want to be most specific. Okay. Natural numbers are like 1, 2, 3. Whole numbers you can add the 0. Integers, put the negatives in there with the 0. Rationals are everything above, which are the fractions that don't reduce. Okay. Irrational numbers are non-repeating decimals. Okay. So basically, square roots don't reduce. That don't reduce to integers. Okay? All right? If a number has both the real and imaginary, it's considered complex. So this would be an integer. This would be a complex number because it's got a real part and imaginary. This is going to have an I with it, so this is just going to be an imaginary. This will be a natural number. So what I want to look at is what's the lowest level I can get to. This is just imaginary. Okay, the lowest level I could get here was rational. Okay, this number, this won't reduce, so this is going to be an irrational number. This is going to be a rational. Okay, this has both parts, so this is complex, and 0 is whole. Now, a 0 is an integer, but what I want to get to is what is the lowest part that I can get to. Okay, like 10 is rational, 10 is an integer, 10 is whole, but the lowest I can get to is natural. So you want to try to get to the lowest possible one. This is technically a complex number, but I can get that also to be an imaginary. Okay, so go ahead and classify those on your own. Okay, a lot of calculations in that, but this will set us up really well for the rest of the unit.